So this is question number 13.5, and in this question we have the Q value of a nuclear reaction A plus B gives C plus D is defined by Q is equal to MA plus MB minus MC minus MD into C square, right? So that is the basic formula of Q value, where the masses refers to the respective nuclei determining for the given data and the Q value of the following reaction and state whether the reaction are exothermic or endothermic, right? So these are the basic reaction, and that is happening here. Now we are calculating this. So first of all, we are going to calculate for the first, that is first reaction, right? So we have protium, then tritium, that is making deuterium, and then deuterium, right? So two atoms of deuterium. So what is happening here is like if we are making two nuclei, one nuclei and two nuclei, and we are splitting it into its constituents, and then we are forming a new nuclei from this. So what is happening, that if the masses of this nuclei old is going to be more than the mass of the new nuclei, that means that the more energy, the more mass delta M is, the more mass is converted in this particular forming this nuclei, the more delta M is converted into energy, right? So that means also that that E delta M in the form of binding energy got released, right, while forming the particular nuclei of that product of atom, right? So that's why if if that last step, if that step is exothermic, that means more stable nuclei are got formed, and if it is endothermic, that means it need energy, and that means ki more unstable nuclei is formed than the older one, right? So this is the basic concept here, and let's solve this. And the basic procedure for solving this is, first of all, you have to write all that. First of all, how you can you have to write this in exam. So you have to write all the data that is given first. So masses of the nuclei of deuterium, then C and Ne, all the things that are given here, right? And now what you have to do is you have to use the Q value. As we know, you have to write that, as we know, the Q value determination requires mass of initial nuclei minus mass of final nuclei into C square, right? And then we note that if the final value of Q is more, that is exothermic, and if final value of Q is less, that is endothermic. Okay, now calculating this value. So first of all, we need the mass of initial nuclei and mass of final nuclei, and that you have to calculate separately here. And after that, you have to calculate the Q value using this. Okay, so you have to put that mass initial, sum of the mass initial minus sum of mass final into 931.5. So one confusion may be there, that this here we have used C square and here I have written 931.5. This is because we know that EB is Q is also written as EB. So delta M into C square, when we do, we get the value in joules. But if we want the value in mega electron volt, we have to do mass in atomic mass unit into multiply with 931.5. Then we get the value of mega electron volt. So that is what I have done here, right? Simple. And now after calculating this, you are going to get that 18.4 mega electron volt, and that means we are getting the value of Q in positive, and that means it is exothermic, and that also signifies that it is a stable nuclei than the previous one, right, than the initial one. So this is the step that you have to follow while solving this, and you can also do the same thing for the second question. Okay, just the step is going to be same, nothing will be changed, but the only the calculation is going to be different. Okay.